What worksheet? 8. Thank you. You need a graphing calculator. This ties into what we did on Wednesday. We talked about binomial probability and the binom PDF button on your calculator. Okay, we're going to use that again today. But we're going to do some additional stuff. All right. First thing we're going to talk about is a random variable. Always confuses me, I don't know why. But a random variable represents a numerical value assigned to an outcome. So if I survey 10 people, do you like Miss Hoffbauer or not? And they answer yes or no, okay? Then we can have 0 people said yes, up to 10 people said yes. That's the range of values for a random variable. That would be a discrete set of data because it is a finite countable. I can count. There's actually 11 possible responses. We could have 0 people up to 10 people, okay? No partial answers, all right? It could also be, we're going to weigh your folder, okay? So that is a continuous random variable because the random variable could range from, 2 grams to 2.34 kilograms or something. Does that make sense? That there's a huge range of values for the weight of your folder, and there's not a countable number. It's a range, okay? Can be tenths, hundredths, thousandths. We can break it down into little pieces. Here's some further examples. The weight of a box of cereal. If this company says we're advertising we're selling these as 15-ounce boxes, and they take every 5th one off and weigh it, is the weight always going to be exactly 15? No. And it could vary by 100th, it could vary by 1,000th, right? Depends how accurate their scale is and whatever. That's a continuous random variable. If we want to know how many cars are in the parking lot on any given day, is that going to be decimals and fractions and stuff? Those are whole number answers, so it can be from 0 to whatever the capacity of the parking lot is, right? So that is discrete random variable. Okay, you tell me. X represents the time to get your food at a fast food restaurant. Anybody work fast food? Do they put the little thing up to the nearest minute? No, it's usually like to the nearest second, right? If you work at McDonald's, I know there's a little clock on the wall. It's timing how often they switch the order thing. Okay, so is that continuous or discrete? Continuous, right? Time, weight, height, generally continuous. Temperature, okay. X represents the attendance at a school board meeting. Okay, well, they can be people with half a brain. We generally count them as whole number of people, right? Okay, so that is discrete. Here's the 2 examples on your sheet. The time it takes a randomly selected classroom to reach this suitable range of temperatures. So it's a whole number. It's continuous. It could take 1 hour. It could take 1.3 hours. It could take 5.6 minutes. Okay, this is continuous. The number of pictures you took at a wedding. The number of times you clicked the button to take a picture has to be a whole number, so it's discrete. No, that's going to be, you're gone if you keep talking. All right. The next question. Sorry, this needs to be slid down. The sample space and the random variable are not the same, guys. The sample space for a familiar theoretical probability of tossing 2 coins, okay? If we're going to toss 2 coins, the sample space is, we could get tails, 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 heads, heads, tails, or heads, heads. 4 ways that could happen, okay? If X is the random variable representing the number of heads, how many heads can we get in 2 tosses? We can get 2, we can get 1, or we could get none. So the random variable is 0, 1, or 2. Discrete, by the way, right? Okay. the probability that we get 0 out of those 4 things in the sample space, how many of them had 0 heads? 1. Tails, tails, right? So 1 out of 4. How many of them had 1 head? Heads, tails, tails, heads. So 2 out of 4, or half. How many of them had 2 heads? 1 out of the 4. Okay? This is called a probability distribution. This is the probability you get each of those answers. It can also be graphed, where you would put the number of heads. You could get 0, 1, or 2, and you make a little range of values for the probability here. I am not going to force you to do a probability distribution graph at any time. If you would prefer to just do the table, it's fine. Okay, even if the homework says do the graph, I don't care if you just do the table. All right, probability distribution. Again, the probability right here has to total 1. The sum has to be 1. And the values in the probability part of the chart have to be between 0 and 1. This is an example. A teacher evaluation form was given. One said the teachers, they asked if the teacher's explanation of the subject was too simple or too technical or somewhere in between. So they were given a score from 1 to 5 by the students. Okay, use the frequency distribution shown. Okay, how many people actually took this survey? Not 5. Everybody okay where we got that information? Frequency means number of people who answered that, or number of whatever, but this is the frequency that this occurred. All right, so how do we make this into a probability distribution? What's the probability that they got a 1? We picked somebody who gave a 1 to the teacher. 1/50th. What's the probability that we picked somebody at random and they gave the score of 2? 8/50ths, and so on. Okay? So the probability distribution, this was 1 out of 50, 2 out of 50, okay? Here's the probability distribution, which you could also graph. What should the sum of all these probabilities be if we did it right? 1. What's the random variable for this question? 1, 2, 3, 4, or 5, right? Okay. It is discrete. All right. A discrete random variable can take on a countable number of values. The probability distribution links each to its probability of occurring. The mean, or the average answer given, okay, which we're going to do a second for that last question, is you take the probability times the number, the score given in this case, or the probability, the random variable. It's random variable times the probability of that occurring. The standard deviation, we're going to use this symbol on our calculator because we're not going to bother with this crazy business, calculating these by hand, okay? This is going to be standard deviation. For today, we're going to use that one. All right. We are also going to be asked to calculate variance, okay, to find the variance of a probability distribution. Subtract the mean from each value and square the difference. And multiply each difference by the corresponding probability to find the sum of the products. The standard deviation is the square root of that. Our calculator doesn't do variance, but if the standard deviation is the square root, standard deviation is the square root of the variance, how could we find the variance if we know the standard deviation? So if they ask for the variance, we're just going to take the standard deviation off our calculator and square it. And you do want to use several places. All right. This is a question we just worked on. The score times the probability of that score, score times the probability, score times the probability, score times the probability, were these numbers. Then they added them all up. This is the mean to interpret that, on average, the teacher received a score of 3.3. Okay? It says down here, you are asked to interpret it. It says a 3.3 indicates on average students felt the teacher's explanations were appropriate. Okay? 3.3. The average the teacher scored is 3.3. All right, this question is on your paper. The first thing they did is they totaled, okay, the number of books bought by each of 100 randomly selected bookstore customers during 1 week. So they asked 100 random people who came in, how many books did you buy? 45 of them said 0. 30 said 1 book. 15 said 2 books. 10 said 3 books. Okay? I need you to understand that if I asked you to list that data, you would write 0, 0, 0, 0 how many times? 45 times. And then you would put in 1, 1, 1, 1, 1 30 times. And then you would put in 2, 2, 2, 2 15 times. Okay? So if you had a calculator that did not allow you to put in a frequency list, to find the mean of this data, you would have to type in that many times. You'd have 100 pieces of data because there's 100 people asked. Does everybody understand that? Our calculator will do a frequency list, even the old ones. I found that out today. All right, so we need to find the mean, and we need to do a probability distribution. The probability distribution, all we need to do is say this totals 100, so what do we need to do to each of these numbers? Divide by 100, which is where they got this, okay? This was the actual frequency divided by the 100 people. So then this is the probability. Okay? Probability distribution. And we could actually put in either this in list 1 and this in list 2, or this in list 1 and this in list 2. It doesn't matter. I did this, I believe. If you guys can't see in the back, somebody could turn the calculator, turn the light off closest to the phone, the switch closest to the phone. Stat, enter, and put these into list 1 and list 2. Make sure you have a list 1 and list 2. Put 0, 1, 2, 3, and 45, 30, 15, 10. Everybody remember how to get there? Stat, enter, list 1, list 2. Now we need to calculate the mean and standard deviation. Because we didn't type in all 100 things, we need to multiply these two lists together. What we're going to do is we're going to go stat, right arrow. We really, even though we have two lists going on, we only have one variable. So we're going to go one variable stats. We put our list in list 1 and our frequency list in list 2. It's second 1 and second 2 to get those if it doesn't say list 1 and list 2 there. If you have an older calculator, you just hit enter and it will bring up one variable stats on your screen. And then you do list 1 comma list 2. I'm not even sure you need the parentheses. I think it'll do it either way. All right, so on my screen, I'm just going to type list 1, list 2 there. Any questions? See if you get this answer. All right, I got X bar, which means mean, is 0.9. All right, do you remember what this meant?
Which, by the way, is what Greek letter is that, guys? Is it a lowercase sigma?
Okay, ooh, the one I have on my thing is really nasty. All right, it's a lowercase sigma. Then we're going to go, what did we find? Right here, 0.99498. I can't read. 0.9949. All right, or 499 even. The reason I go out so many places is the closer you are to 1, when you square it, it's going to be really close to 1, okay? So there's not much difference if you don't go out several places. Then to find the variance, you go that number, okay, thanks, squared. Okay? So the mean was 0.9, which means the average number of books bought was what? The average customer bought 1 book. Yes? Okay. So it says find and interpret the mean. The mean was 0.9, so it says on average each customer bought 1 book. The variance was 0.99 and the standard deviation is 0.995, roughly. All right, we're going to do it with this. Can you work on that? Yep. The variance, you have to take the standard deviation that's on your calculator screen and square it. Yes. There is another way. Variance is on your calculator somewhere. I don't know if I just go to the catalog. It actually does variance, I think, but I don't know. You'd have to tell it. Is it, do you do still list 1 comma list 2? I don't know where you find it, though. I found it in the catalog, but did you find it somewhere else? Well, that's interesting. It gave me a variance of 1, not 0.99. What? Yeah. Anyway, okay. I feel like it only did list 1, because the variance in list 1 was 1, because all of them are 1 apart. I feel like it didn't do list 1 times list 2. I wonder if we could put in times. Okay, I'm getting way off track here. No, that's not a good choice. Okay, anyway, we're on the next question. What are we going to do first to make this a probability distribution? Okay, we should read the question. The table shows the number of medical tests that 15 randomly selected patients entering a particular hospital received in a day. So they asked how many people? 15. How many medical tests, how many tests did they run on you today? Okay. Those 15 people said 0, 1, 2, or 3. Which seems kind of ridiculous to me, because it seems like if you're in the hospital, they run 1,000 tests, right? All right, we need the probability here, not the frequency. So what do we have to do? Divide these by 15, which is 0.4, 0.33, 0.2, 0.067. Thank you very much. Now we're supposed to find and interpret the mean and state the variance and standard deviation. I'm going to go to my colorful calculator this time, just because you can see it a little better. So stat, arrow to the right. Nope, don't arrow to the right till you put the numbers in. Stat, enter. Oh, Hofbauer's a cheater. I did 0, 1, 2, 3, 6, 5, 3, 1. You can also enter the probability in as list 2. You will get the same thing, okay? I'm going to go stat, right arrow, choice 1, list 1, list 2. Am I going too fast? Need help? No? We good? Oh, that was interesting. It just made that bigger. Look at there. So if I do that, learn something new every day. All right. What are we going to put here? The mean is 0.93. What does that mean? On average, each patient received, had one medical test, right? The standard deviation, 0.9286. The variance, if I did list 1 times list 2 and had that entered into list 3, it didn't work. Oh, it did work. And then I want the variance of that list. Did anybody figure out where variance was?
Yep.
Where is it?
Second stat, and then open math. It's the last one.
Oh, the very last one? Okay, so now I want the variance actually of list 3. Oh, that's not where I want it, though, is it? Be faster just to square the standard deviation. I'm thinking, what do you think? By a million years? That's not right. Okay. Apparently none of my attempted methods are working. 0.9286 squared was, all right, moving on, since I wasted time. Binomial experiment. We did this already this week on Wednesday. Okay? For something to be a binomial experiment, it must be repeated a fixed number of independent trials. In other words, the probability each time has to be the same. Each trial has only 2 possible outcomes, success or failure, and the total of that probability has to be 1. So the probability of success is P, and 1 minus that has to be Q, the probability of failure. The random variable X represents the number of successes that we want. Do you remember doing this with the crazy golf guy? He hit 14 out of 18, or what's the probability he hits 18, 14, if he's a 70% chance of hitting, 30% chance of not hitting. Remember doing that crazy business? Okay. But we learned a shortcut, yes? We love this button on our calculator. Okay? Binom PDF. We'll get rid of all that calculation. That's not exactly what this question is asking. We'll get to some, but this question, please pay attention, because this is a theoretical question. Okay? It says, determine whether each experiment is a binomial experiment. If it can be a binomial experiment, state the value of n, which is number of trials. You might want to write that down somewhere. What is p? Probability of success. And what is q? Probability of failure, or 1 minus p. All right, then list all possible values of the random variable. All right, we got to read this carefully. The results of a school survey indicate 68% of the people own, I'm going to go with iPod, okay? 6 students are randomly selected and asked, do you own an iPod? The random variable represents the number of students who say they do own an iPod. All right, is this a binomial experiment? Is each student's answer independent of everybody else's? Is there a set number of people they asked? Is the answer success or failure? And do we know the probability of success? Okay. So N is the number of students asked, which is 6, right? Okay. P is the probability they say yes, 0.68. Q is the probability they fail or say no, which was 0.32. Now we're supposed to figure out what the random variable is. If we want to find out the number of students who own one, what's the possibility of all our answers? Everybody get it? If we ask 6 people, we could have 0 people say they own one, 1, 2, 3, 4, 5, or 6. All right? Doesn't ask us to do anything. We don't have to create a probability distribution. All right, is this a binomial experiment? 5 cards are drawn at random from a deck to make a hand for a card game. What's the variable is the number of spades we get out of 5 cards. Why not? If you're dealing a hand to somebody, is the probability the same that you'll get a spade every time? The first time, there's 13 spades out of 52 cards, but the next time you go, there's 12 out of 51 and so on, right? So is the probability set each time, independently of the next card? No. So that is not a binomial experiment. Here's 2 more examples. The results of a survey indicate that 61% of students like the new school uniforms, 24% do not. 20 students are randomly selected and asked if they like the uniforms. The random variable is the number who said they do not like the new uniforms. It's a tricky question. I wanted to go with yes, and then I looked at the numbers. Did everybody say yes or no? Okay. We have 61% and 24%. So we obviously have some other category, right? Somebody said, yeah, kind of like and kind of don't. So is it a 2 success or failure? No. Okay, they're trying to trick you. Next question. You complete a test by randomly guessing the answers to 20 multiple choice questions. Each have 4 answers. Okay, only one of which is correct. The random variable is the number of correct answers you get. Each question you're either going to get right or wrong. What's the N? 20 questions. P is 4 choices, right? And one of them's correct. So 1/4. Q is 3/4. The random variable? The random variable represents the number of correct answers. So you could get 0 to 20, yes? Okay. This is on your paper. A survey found that 20% of Americans have visited a doctor in the past 6 months. 5 people were randomly asked if they went to the doctor in the last 6 months. Construct, it says and graph, but remember I said you don't have to graph. Binomial distribution for the random variable x, representing the number of people who said yes. So what is our random variable? Did you go to the doctor and you said yes? Out of how many people? We asked 5 people. What's the probability they went to the doctor? 20%. Okay. If we were doing it by hand, we would have Q is 0.8. And we would have to do 5C0 times 0.2 to the 5th times 0.8 to the 0. But did we want to do that all the way down this chart? What did we learn to do? Binom PDF. What did you enter for the first one? 5.2 and first one is 0, right? Then 1, then 2, then 3. Type the first one in and see what you get. Do you remember where it is? Did we use it once today already? Not today? Okay. It's under second vars. Got to go all the way down. Make sure you do not pick CDF. On some calculators, I think it's choice 0, but mine's choice A. Okay. 5 trials, 0.20. I want 0 of them to say they went to the doctor, so I get 0.32. Your paper rounds it to 0.328, right? Okay. I got 32768. All right, what is the chance? What is the probability at least 4 people said yes? At least 4 people. That means who are we counting over here? Counting these 2. Could you do those 2 on your calculator? Because I'm not happy with the way they rounded. Binomial PDF 5.2 and what? 4? Okay. And then do 5.2 and 5. Scientific notation, but it's 0.00032. If we actually add those all the way out, we get 0.00672, which actually would be 0.7%. Not a big deal. But it's good practice. You know how to find all those things, right? We okay? Faisal, you okay? All right. A survey found that 60% of American victims of healthcare fraud were senior citizens. Okay? So, they said they surveyed people who were victims of healthcare fraud and asked them their age to determine if they were a senior citizen or they weren't a senior citizen. All right? So 6 victims of healthcare fraud were chosen at random. Their ages were recorded. Construct a binomial distribution for the random variable x representing the number of senior citizens chosen. How many senior citizens could we have chosen? 0, 1, 2, 3, 4, 5, 6. Okay? How are we going to find those? Binomial PDF, where we put in what? 6, comma. P is 0.6. And for the first one, we're going to put a 0, right? One more time, Ben, louder. Okay, who's got 1 for me? And remember, I just do second enter and change that last number. I don't want to keep going and find that stupid button. Anybody else getting these numbers? Yes, you got 3 yet or not? One. All right. Find the probability that at least 3 of the victims will be senior citizens. Which ones are winners? 3 through 6, right? So we have to add up all the probabilities here. There's 2 other ways we could do that question. Anybody think of either one? What are these total? 1, right? So we could do 1 and subtract those 3. I don't know that that's a whole lot shorter, right? But that would work. There is also on your calculator binom CDF. That is the combined probability. You still would put in 6 and 0.6, but you have to say less, that this means 2 or less. Now, did we want 2 or less? So we'd have to do 1 minus that, because it's 1 minus the 2 or less. It adds down. Most of us won't use that because you get confused. I get confused. Is it adding down or is it adding up from 2? 0.8, 0.7, what did it come out? 82% roughly. Okay. Did anybody try this? Did it come out 0.82? Okay. Faisal's always checking me. All right, guys. This question we should be good at. All right. Mr. Hanlon distributed a 5-question multiple choice quiz to his students. There are 5 choices for each question. Ashley guesses on everything. What's the probability she gets 3 correct? Binom, PDF. No, it's not 3/5. What are we putting in? N is number of choices or trials or questions. 5. Probability of success. 1/5 or 0.2. This particular question, number of successes is 3. Anybody get an answer? So about 5% chance that she gets 3 right. All right, what if we change it to 4 choices? Be careful. Are there still 5 questions? What changed then? It's 1 out of 4 chances, or 0.25, that she gets it right. It says use part A, so she still wants to get 3 right. Should this go down or up? Okay. What is it? Okay. What is the probability in part A if the quiz was all true, false? Still 5 questions. It's not a half, because the probability that she gets 1 right is a half, but the final answer is not a half because she's getting how many right? 3 out of 5. Now, is a 3 out of 5 passing? Yes. So is there a 31% chance that anybody who guesses passes this? I was thinking that was yes, but there's actually a little bit better percent chance, because that's how many get exactly 3 right. We would have to add in how many get 4 right or 5 right, which aren't going to be very many, but it's going to improve the chance that they pass. Just guessing. That's why we don't give just true false questions. All right. Expected value, guys. One more concept today. Expected value. I need you to follow along closely here. If we have a raffle where 500 tickets are sold, okay, we're going to have one prize of $100. So the probability is 1 out of 500. We're going to give away one $50 prize. We're going to give away one $10 prize. And the other 497 tickets are losers. Okay? What is your expected value, which means if you did this, you decided you were going to do this every day, you're going to participate in this raffle, what over the long run, what would your expected earnings be? Well, what do you actually earn if you win the $100 ticket? Only $99. If you win the $50 ticket, if you win the $10. But every other losing ticket, you've actually gone what? In the hole $1. Ready with me? Okay. So to find your expected earnings, or your expected value, average earnings, you take this $99 times this. $49 winnings, this percent chance, this, and it turns out negative 0.68. Now, can you ever on one single day lose 68 cents playing this game if you only play it once a day? No. It's an average. As you approach a whole bunch of times, you would average 68 cents lost. Here we go. We're going to try this question, which you don't have, I don't think, and then we'll do the two you have. A water park makes $350,000 when the weather's normal. They lose $80,000 when there's more bad days than good. Okay? If the chance of having more bad days than good is 35%, which is that the probability of? What's the chance that it's good weather then? 1 minus 0.35 is? Okay. So we add those values together. The chance that they win or they profit $350,000 is this. The chance that they lose $80,000 is this. What is their average expected profit? Or it's called expected value. Almost $200,000, right? Okay. 2 questions on your worksheets. The first one needs a little clarification. A resort is planning a bicycle race. The cost of sponsoring the race is $8,000. So they're in the whole $8,000, okay? The resort expects to make $15,000 on the event. We have to decide if that's profit or that's just what's going to come in. The other classes decided they thought that's what came in on the day of the race. So the actual profit would be what? Yeah, 15,000 minus 8,000. I'm not sure how they actually intended this, but it would be $7,000 profit, okay? There's a 30% chance of a hurricane arriving the day of the race. If this happens, the race will be canceled and not rescheduled. What are their expected profits? So 7,000 is their profit. What percent of the time? 0.7, right? Because 70% chance that there's no storm. They're going to lose how much money? 8,000 that they've spent to put the race on. How often? 30%. What does that come out? So if they did this a whole bunch of times, they did this every year, and every year on the day there was 30% chance of a hurricane, their expected profit would be $2,500. This is more realistic. An insurance company insures a painting worth $20,000 against theft for $300 per year. So the guy's paying $300. The income, we're supposed to be the company, okay? The company's making $300 every year, okay? The chance that it gets stolen is 0.002 every year. If it were to get stolen, what would the company make? Negative $20,000. They'd have to pay for the painting. Okay, what's the probability they get negative 20,000? What's the probability that they just get to keep the $300 that people gave them? 998, right? 0.998. Okay, so multiply those out, and what do you get? What is it? Okay, this is how companies actually decide what they're going to charge somebody for that policy, okay? What's the probability that we're going to have to pay on this, blah, blah, blah. Okay. This is the assignment. I need you right now to take out worksheet 6 quickly because there's 2 questions I want to talk about.